Hello, everyone, and welcome to ROKStudios. I'm Stan Miller. I'm the PR and Analyst Relations Manager for Rockwell Automation in the EMEA region, and I'm joined today by Andrew Weatherhead. He is the Chief Technology and Digital Officer for Sensia Global. Andrew, welcome to the studio.
Well, thank you. Nice to be here.
So, today we're here to talk about intelligent action and how to support macro and micro efficiency gains in manufacturing. But before we get into that topic, could you just give us a little background about Sensia?
Sure. Yeah. So Sensia was formed 4 years ago, and it is a joint venture between Rockwell Automation and Schlumberger, or now SLB. And really, Sensia was formed on the premise that combining automation expertise with petrotechnical expertise, we can solve new challenges in the oil and gas industry.
All right, fabulous. So let's get into the topic. And my first question I'd like to ask is, could you help us understand how do inefficiencies in manufacturing impede profitability and what are the benefits that businesses can generate by tackling them?
Sure. I'll start with maybe illustrate this through a few examples, if I may. So, the first example I give is an operator in a control room, and they have a series of monitors in front of them, and those monitors are linked to multiple systems. And on a particular monitor, they would have a flashing light, and that flashing light really indicates that there's a problem, something that they need to address, needs their attention. But at any given time, there are many of those flashing lights. Some of them are visible on the pages that they have called up in front of them at that particular time. Others are in the background, out of their view. And then there are another set of indicators that don't exist. And those are the pieces that need to be inferred by linking information between multiple systems. So if you put yourself in that operator's chair, they have a few flashing lights in front of them that are visible, some that aren't, and some that don't exist at all. So if you ask that operator, how do I optimize my process or my manufacturing facility, right now based on this point in time? How do I have the biggest impact on profitability? Or it could be the biggest impact on my sustainability, my decarbonization goals. That operator is really challenged to answer that and to understand that. So if you look at that and all the possible opportunities and business cases that exist behind that within a facility to be able to optimize processes, to be able to draw operators' attention to the problems that are the most emergent, the things that need their attention the most, the ones that are going to control the bottom line or affect the bottom line. Those are real opportunities for gaining efficiencies. Another example would be, in terms of emissions reporting, for example. So it's a very topical at this point in time. Many companies or most companies are working on and have emissions reporting, but it's primarily done manually. So again, if you put yourself in the shoes of those people, they have changing standards. Things are getting tighter. Obviously, the impact from their company's reputation, not just profitability, but the risk that emissions pose if their emissions exceed their stated goals. So there are real opportunities there to automate those pieces that exist, so that instead of having a backward look at what has happened, which is the current state, you're looking at the past, and you really have little opportunity to control the outcome. So by automating those processes and automating the reporting, you can pivot that from in a more proactive sense and be able to take control of emissions, for instance.
Got it. Andrew, how do intelligent actions help manufacturers run more efficient operations? Those examples were great, but can we maybe dig a little bit deeper?
Sure. Yeah. So I'll maybe just cover the concept of intelligent action, and it comes from a CTO's point of view. But if you consider a graph, and on the y-axis of this graph is impact. And that could be impact, again, to profitability. It could be impact to safety. It could be impact to compliance or emissions, for instance. And if you take profitability, for instance, on this y-axis, if you look at an operational situation that may exist that is having the most negative impact on my profitability, that would be the highest point on the y-axis of this graph. Now, the x-axis of this particular graph is time. So as that situation exists over time, the impact is cumulative. So really, with that graph in mind, it's obvious that solving these situations as quickly as possible, or better yet, preventing them from occurring, will drive the best improvement of profitability, safety, and sustainability. So that the time between detection and correction, that's intelligent action. So it's really all about optimizing and controlling those variables or those impacts.
Okay. In what ways did they help support both macro and micro sustainability objectives? Help us understand that.
Yeah, okay. So again, if I took a micro objective, and again, I'll kind of maybe just circle back to the emissions topic. Again, very topical today. If we look at emissions reporting being done manually today, Excel spreadsheets, calculations, all those things, automating pieces of that. So instead of looking at the problem as one big, giant problem of getting an automated kind of emissions report, it's really a series of incremental projects or micro projects. So I'm going to focus on these things. I'm going to collect the data from the systems. So I'm going to take the data and get that data kind of contextualized and available within a single environment, and then apply the calculations I need to calculate those emissions, but then also apply uncertainty. So with compliance, it's not just about the quantity, but you have to prove from a regulatory standpoint that you fall within certain uncertainty boundaries that are stipulated. So that's an example of how micro projects or micro solutions can cumulatively add up over a period of time and eventually get to a point where you have a dynamic understanding of what your emissions are at any point in time. And then if we look at on a macro sense, and again, I'll stick with in the area of sustainability. In the oil and gas industry for years, we've had the concept of hydrocarbon accounting, and really what that means is starting in an upstream environment, there's production allocated to individual wells. And at some point in time, you have to validate what came out of those wells, and you do what's called a back allocation. So you do a measured outcome with informed qualitative aspect to that, and you're able to then back allocate so you actually understand what came out of each well. So that's one component of it. As the hydrocarbons enter a pipeline, they pass through different points of custody transfer. And at the end, there's a final consumer of that hydrocarbon, and everybody has their own metering all the way along this pipeline. And at the end, there's payments made all the way across that, and then there is an adjustment that's done all the way back because these different measuring points have different accuracy. There's different things that can affect how much hydrocarbon actually comes out of the end of a pipe, for instance. So this concept is called hydrocarbon accounting, where they're able to understand at the end how much they got, what the value of that is, and then they either back charge or all the way down that custody transfer chain. So if you look at where carbon capture and utilization and storage is going in the future, it's a very similar problem where you have emitters that are emissions. So each you have macro emitters and micro emitters, but then you have various forms of carbon capture. So there's a number of different methods. So those methods are going to be transported in some way, shape, or form, whether it's through a vessel, a tanker, for instance, or whether it's in a pipeline. the carbon will be sold and pass through several points of custody transfer, just as I described with the hydrocarbon. It's the same situation in reverse, because at the end of the pipeline, they're actually going to inject into depleted reservoirs. So use the infrastructure that exists, have injector wells, and inject that into the reservoir. So the same kind of challenge from a carbon accounting standpoint exists, where there's going to be points of custody transfer. There will be injections into these individual wells, and you're going to have to control or understand how much was injected in each of those wells, because it's important that as you fill the reservoir, you fill it in a certain way, because that's what you need to do in order to maximize how much you can store in that reservoir over time. And that same set of adjustments or back allocations or whatever you want to call it, back charging, is going to exist across that value chain. So from where the future is going in that space, it's going to be very akin to hydrocarbon accounting. So carbon accounting is an example of a macro solution that we see on the horizon.
Right. Andrew, thank you so much for joining us in the studio today. We really appreciate your time.
Well, thank you very much. Great to be here.
And thank you for watching. If you'd like to learn more about industrial automation and digital transformation, visit www.rockwellautomation.com.